Hey guys, these notes are for solving inequalities. Our essential question is, when do you flip the sign when solving inequalities? So first of all, let's go over what an inequality is. We have 4 types of inequalities, and we've seen this since elementary school. The first one I'm going to talk about is the one that looks like this. And this one is going to be the less than symbol. And if this is something that you've struggled with even when you were in kindergarten or first grade or whatever, to remember that this one's the less than one, you can think about it as a giant L that's saying less than. So this thing is like kind of like an L that's slanted a little bit, so it's a less than symbol. The second type of symbol we have is less than or equal to. Okay, so that's our second type. I'm going to go ahead and move this up a little bit. All right, the next type we have is the one that is facing the other way. Well, this one's going to be greater than or more than, which means our very last inequality sign is going to be greater than or equal to. All right. So moving on, I have 2 star points here. The first star point is when solving an inequality, it has the exact same steps as solving equations. So you do exactly the same thing. You're still trying to get that variable by itself, so that big goal in mind is to still get that variable all by itself. All right, but we have one special rule when we're talking about inequalities. When you multiply or divide, so either time when you multiply or divide, doesn't matter which one, by a negative number, so anytime you're multiplying or dividing by a negative, you must flip the sign. Okay, you must flip that inequality symbol. So for example, I have some examples here. So if our first sign is a less than sign and we would divide or multiply by a negative, it would flip to a greater than sign. A greater than or equal to sign would flip to a less than or equal to sign. A greater than sign would flip to a less than sign. And a less than or equal to sign would flip to a greater than or equal to sign. So it just depends what your sign is, but it's always going to flip the other way. So it will flip when you multiply or divide by a negative. So we'll get there and hopefully we remember. All right, so how to graph an inequality. So not only do we have to solve, we also have to graph. So we have just 3 steps. We always want our variables or our letters on the left side. And that just makes things a lot easier for us, and if it's on the left side, then everyone's on the same page. So even if it's a pain to have to move your variables to their left, even though they're all on the right, just move them. It'll make everything a lot smoother. All right, number 2. If you have a less than or greater than sign with no equal to, with no lines underneath, these are going to have unshaded circles, or what I call open circles. Okay? Now you have less than or equal to or greater than or equal to, you're going to have a circle that's filled in when you have your number line. So actually, I'll even draw a number line and show you what that would look like. So you would have an open circle there, and for the next one, you would have a closed circle. Okay? So one has an open, one has a closed. And it just depends on what your inequality sign is. Now, for shading our number line, when we graph our inequality, the first section here, I have a less than or equal to or a less than. And when it's less than, I'm going to shade to the left. Okay? And the reason why I shade to the left is because all the numbers that are less than are on the left side of the number line. And if I have a greater than or equal to or a greater than sign, then I'm going to shade to the right. And we'll see this in action later on with the next 5 examples. So going into number 1, I have 2 times x minus 7 is greater than or equal to 4 minus x. I'm still going to use the same steps I would to solve this like I would solve an equation. So I'm going to go ahead and I'm going to draw my line down the middle. So instead of an equal sign, I just have an inequality, but I treat it the same. And I still want to get these variables on the left, but before I can do that, I need to get rid of these parentheses. And to do that, I would have to distribute. 2 times x is going to give me 2x. 2 times negative 7 is negative 14. And I'm going to keep this inequality sign facing that way. I want to keep it that way, and I want to keep writing it over and over again, because we're going to want to write an equal sign on accident, and it happens. And I say that because it does happen. All right, now, the next step is to move all of my variables to the left side. So I notice that I have a negative x on this right side, and I want to move it. In order to move it, I'm going to have to add x because it's opposite. And I would add it to the 2x because those are like terms. So then I would have 3x minus 14 is greater than or equal to 4 because the x and the plus x cancel. Moving on, I'm going to move my 14 over by adding 14 because it's already negative. Cancel those out. I have 3x is greater than or equal to 18. And my last step here is I'm going to get my x by itself, and 3 and x are combined by the operation of multiplication, so I do the opposite by dividing. And I have x is greater than or equal to 6. So that is my answer. Let me make this 3 a little bit smaller. Shrink it. Come on. Shrink. There we go. Move it there. Okay. So that is my answer. I'm going to go ahead and write that over here. X is greater than or equal to 6. So this is my answer for number 1, which means x is any number, but x is any number bigger than or equal to 6. So let's go ahead and graph this. So using my how to graph an inequality, I want my variable on the left side. So it is on the left side. Number 2, I have to figure out, is it going to be an open circle or a closed circle? Well, since there's an equal to symbol here, I'm going to have a closed circle, which means it's going to be shaded in. And since x is greater than 6, since I have a greater than sign, I'm going to be shading to the right because all the numbers bigger than 6 are to the right. Now there's one more thing I haven't done, and that's say that it's 6. So this number line is super easy. I don't have to write all the numbers out or anything like that. I just want to write the 6 and then shade it to the right. All right, moving on to number 2. I have 5 times 1 plus 4n is greater than or equal to 50 or 80. Oh my gosh, I can't read it. 85. Okay, so now I'm going to go ahead and draw my line down the middle. And I'm going to do 5 times 1, which gives me 5, and 5 times 4n, which gives me 20n. And I have greater than or equal to 85. All right, moving on. I still want to keep my variable on that left side, so I don't want to move the 20n anywhere, but I do want to get rid of that 5, and I would get rid of it by subtracting. That would cancel, and I would have 20n is greater than or equal to 80. Now after this step, I need to get n by itself, so I'm going to divide both sides by 20. And I would have n is greater than or equal to 4. All right, so I have n is greater than or equal to 4. That's my answer to my inequality up there, which means n can be any number as long as it's greater than or equal to 4. So let's start graphing. Well, I know this is going to be a closed circle because it is equal to, and I'm going to have a 4 down here. I'm going to label a 4, and it says n is greater than. And if I have a greater than sign, then it's going to go to the right because all the numbers bigger than 4 are on the right of the number line. All right. Number 3, negative 2 times 4x minus 8 is greater than 4 times x minus 2. So let's go ahead and draw our line down the middle. Okay, and let's go ahead and distribute. So on this problem, we're going to have to distribute on both sides. So I'm going to distribute my left side first. Negative 2 times 4x is negative 8x. Negative 2 times negative 8 is positive 16. 4 times x, oh, and I forgot my inequality, so I still have a greater than sign here. 4 times x is going to give me 4x. 4 times negative 2 is negative 8. Now, again, I want my variables on the left, so I'm going to go move that 4x to the other side by subtracting because that 4x is already positive. And I would subtract it from the negative 8x because those are like terms. These 4's will cancel. I have negative 12x plus 16 is greater than negative 8. My next step here is to get rid of that 16, so I'm going to subtract 16 on both sides. Negative 12x is greater than negative 24. All right, moving on. I want to get that x by itself. So I'm going to divide both sides by negative 12. Okay, negative 12 divided by negative 12 is 1, so I just have an x left over. And then I also notice, hey, I just divided by a negative number, which means I have to flip this inequality sign around. So now it's going to face the other way, and I have negative 24 divided by negative 12, which gives me positive 2. So don't forget, that tricky. It's very tricky because it's flipping, so you have to make sure you catch it. It's a lot of things to remember, but you got to make sure you catch it. All right, let's graph this. Am I going to have an open circle or a closed circle here? Well, if I look up at my steps, it says I'm going to have an unshaded circle because there is no equal to line. So this is going to be an open circle, and then I'm going to have a 2 down here. And it says x is less than 2. Well, if it's a less than sign, all the numbers less than 2 are to the left. Whoops. Ugh. I'm like not happy with how I'm writing this line at all. Okay, there we go. All right, moving to number 4. 3 is less than or equal to 21 minus 4x times 2/3. So I'm going to go ahead and draw my line down the middle. And this one's a little bit different because it's kind of backwards for us. So I'm going to go ahead. First of all, I need to distribute. So I'm going to do 2/3 times 21, which is going to give me 14. And then 2/3 times negative 4x, which gives me negative 8 over 3, which is going to be negative 8x over 3. And just a reminder, 8/3 x is the same thing as 8x over 3. So that's why I'm writing it that way. Oops, let me see red. And then I'm going to keep my sign the same, and I still have my 3. So all I did there was distribute. It's just a little ugly because we have some fractions. And I will warn you that it's going to be a fraction in your answer. It's not very pretty, but that's what it is. All right, I still want the x by itself. However, I need it on the left. So I need to move my x to the left side. So I'm going to go ahead and I'm going to add 8x over 3 to both sides. But what do I notice? 8x over 3 and 3 are not like terms. So this is what's going to happen. These guys will cancel, and I'll have 14 left over here. And on this side, I can't combine these. So I just have 8x over 3 plus 3. Or, in other words, I can have 3 plus 8x over 3. Doesn't really matter, it's addition. So those aren't like terms, so I just have to write it next to it. Can't combine, so that's just what it is. Okay. Now, I still need to get that fraction and that x by itself, but I first need to subtract 3 on both sides. And I have 8x over 3 is less than or equal to 11. I need to make this line a little bit longer. Okay, and here, before I can get x by itself, right, I have to multiply both sides by 3 over 1. Because it's currently being divided by 3, so the inverse would be to multiply. So this problem is a lot of steps. Well, these 3's cancel, and I just have 8x is less than or equal to 33, because 11 times 3 is 33. And my last step here is going to be dividing by 8. Now, I'm not sure if you noticed, but we haven't divided or multiplied by negative. So in this case, I would not flip my sign. I only do it if it's a negative number. So I have x is less than or equal to 33 over 8. Now, I can explain that a little bit more in class, but I would like you to leave it as an improper fraction rather than as a decimal, because sometimes our decimals don't end very nicely. For example, 1 over 3 is just 0.3 repeating. And I don't really like the 0.3 with a bar on top. It's not really proper, so we're going to leave it as a fraction. All right, so now we have to graph. I forgot to write a number line over here. So let me draw a number line. Okay, and I have x is less than or equal to 33 over 8. Well, regardless of what my number is, I know I'm going to have a closed circle, right? Because it's equal to, less than or equal to. And I have 33 over 8, so it doesn't matter what number it is. And then it's x is less than or equal to 33 over 8. So if it's less than, I'm going to shade to the left. All right, I'm going to go ahead and move this because it's a little too large. Right there. All right, number 5. So same thing, let's go ahead and draw our line down the middle. And I notice that I have some parentheses over there, but don't forget that there's a negative sign, right? But there's technically a negative 1 here. So let's get rid of those parentheses. So I know I have negative x minus 5 is greater than. Negative 1 times x is going to be negative 1x, or just negative x. And then negative 1 times negative 4 is going to be positive 4. Now my next step is going to move all my variables to the left side. So I would add this x over here and add this x over there. Well, negative x plus x is going to cancel, but negative x plus x on the other side also cancels. So now I have negative 5 is greater than 4. Well, is that true? Is negative 5 greater than 4? Is it bigger than 4? No, it's not true. So this is going to be no solution. And sometimes that happens. You don't have a number line that you can graph, and that's just what it is, All right. Now we have some word problems. This is the last section of the notes, just one problem. We have some keywords. We have at most, no more than, maximum, less than, at least, no less than, minimum, and more than. So we have lots of keywords here, and these are keywords that are going to indicate us what type of inequality signs we need. So let's talk about this. When I say at most, if I say a plane can hold at most 5,000 pounds, it means it needs to hold 5,000 pounds or less. It can't hold more than 5,000 pounds. So this is going to be less than or equal to, because it could hold 5,000 pounds. No more than is the same thing, right? The plane can hold no more than 5,000 pounds, so that's also less than or equal to. Maximum is the same thing. A plane can hold a maximum of 5,000 pounds, so it can hold 5,000 pounds or less. And then less than is just going to be a less than without an equal to line, because if I say less than, I want strictly less than that. So if I say less than 5, I can't be 5. It has to be a number less than 5. All right. Now we have at least. If I say you have to be at least 4 feet tall to ride the ride, it means you need to be 4 feet tall or higher. So this would be you have to be greater than or equal to. No less than is the same thing. You have to be no less than 4 feet tall. Minimum. You have to be a minimum of 4 foot tall. So you have to be 4 feet or higher. So greater than or equal to. And then more than is strictly more than. So just greater than, no line underneath. So I kind of separated these to our less than signs over here and our greater than signs over there. Some of them have equal to bars, but it just depends on the wording. All right. So number 1 is an important problem. We do see this again. So Joey's cell phone plan gives him 5 gigabytes of data for $20. Each additional gigabyte costs him $2. He wants to spend no more than $80 this month. What is the maximum amount of data he could use? All right, so we are given 5 gigabytes of data for $20 a month. So no matter what, every month you're going to be charged how much? You're going to be charged $20, and that's a given. You're going to be charged $20 every month no matter what. Now, I also see that for every additional gigabyte, it's going to cost us or cost him $2. Well, it's going to cost him $2, and we don't know how many additional gigabytes, right? It doesn't tell us how many additional we can have. So I'm going to have X, but how much does it cost for each one? 2. So I have $2 for every gigabyte, but I don't know how many gigabytes yet. Now, I'm going to add this amount to my $20 because that's the additional of what I'm using each month. I know I have $20 being charged, plus $2 for every gigabyte that I use extra. All right, the next part says he wants to spend no more than $80. Well, let's look at our keywords here. No more than indicates to me that I'm going to have a less than or equal to sign. So this amount here has to be less than or equal to $80. Okay, I can't have more than $80, but I could have $80. And then from here, you're going to go ahead and solve. So let me go ahead and write it here. Let's draw our line down the middle. And let's start to solve and isolate x. Well, the first thing I would do is I'm going to subtract 20 on both sides. And I have 2x is less than or equal to 60. And then next I'm going to divide both sides by 2. And I get x is less than or equal to 30. So my solution here is x is less than or equal to 30. What does that mean? It means he can spend or he can use up to 30 extra gigabytes a month, right? So he can use 30 extra. He already has the 5, so you can have 30 extra, which means in total he could use at most 35 gigabytes because he has the 5 at the beginning for $20 plus the 30 that we could use. All right, so that is it for your notes for solving inequalities. If you have any questions, please feel free to come in and ask.